Thank you for inviting me to speak today on our research. Today, I'll talk about phosphorus runoff. This is a project that NREC funded, and we really appreciate that. It was developed by Dr. Fernandez at the University of Illinois. Myself and Chris Rudisell, research technician, worked closely with Dan Schaefer on this project, the title of which is Phosphorus Runoff from Surface and Subsurface Fertilizer Applications in No-Till and Strip-Till Fields with Minimal Slope Gradient in Central Illinois. It's a long title. We really want to thank the farmer cooperators we had with this project. Without them, it wouldn't have happened. We have Eric Rund, David Schaefer, Denny Reefsteck, and Jerry Christian. So why are we concerned about phosphorus runoff? The main issue that we've all heard about is the Gulf of Mexico hypoxia zone. And phosphorus is the main nutrient that's limiting that algae growth in these zones. The Gulf Hypoxia Task Force initiated a lot of the conversation about reduction of the phosphorus runoff. They set a goal to reduce the Gulf hypoxia zone by 45% by the year 2015. That turned out to be a lot more of a complex issue than initially thought, so they've extended that goal another 30 years to 2045. The EPA is in charge of monitoring the phosphorus loss from Illinois and other states, and they suggested that all states come up with their own nutrient loss reduction strategy. Illinois is doing so. The strategy in Illinois states that we think up to 48% of the phosphorus that's leaving Illinois is coming from agriculture. So the nutrient loss reduction strategy is working on goals to reduce that loss from Illinois by 25% over the next 10 years, and ultimately up to that 45% reduction. So what we know about Illinois, we have a large portion of the land that's fairly flat, 0 to 2% slope. But what we've seen lately in the last couple years is that large precipitation events can still cause major runoff from these fairly flat areas. So with the lack of research that we've seen on conservation practices, P rate, and P fertilizer placement method on runoff, we decided to develop this project to determine the effect of P placement and tillage on P concentrations. We were fortunate to have an ongoing study that we could utilize for this project. We had 6 years of established treatments of no-till broadcast, strip-till broadcast, and strip-till deep placement fertilizer applications. Of the treatments at this project, we chose 3 P rates, 0, the 92, and 161 pounds of P2O5 per acre. This is the low, medium, high rates of that study. And we were able to utilize 2 fields and 2 replications of this project. To set up for runoff collection, we went out to these strips that were established and installed metal and wood microplot borders to isolate that area that we were going to study for runoff. We went out each year following fall fertilizer applications. We averaged our rainfall events 2 to 3 weeks after fertilizer application. Each rainoff event, the runoff was 30 minutes long, and of that 30-minute runoff event, we captured the entire volume, quantified that, and then subsampled that for analysis of the 3 different forms of phosphorus in the lab. What we also did at that time was the soil sample the top inch, so just the surface available phosphorus from the soil at that time of the event. To create the rainfall, we constructed 4 of these towers. That's me over there hiding underneath that camo hat. Each tower had its own plumbing system to regulate pressure so we could consistently provide rainfall to that plot. That connected with a plumbing system that would feed 1 or all 4 of the towers at a time. You can see we had a system of tanks and transfer tanks that would bring water from town, and then we would then transfer that out into the field and be able to keep the rain towers going for as long as needed. Each tower had one nozzle in the top that could supply rainfall at a rate of 2 inches an hour. This is equivalent in Champaign County to a 10-year storm. That one nozzle was able to rain one pattern that would cover the entire mica plot. As you can see here, each tower had a curtain that could be raised to prevent the wind from moving those rain droplets off target. And we also had an anchor system for each tower, because once you raise those curtains, they became giant kites if you weren't careful, which was nice that you could lower them and then we can move them on to the next plot. Here's a great image that Dan caught of rainfall evenly dispersed across the microplot. And once that runoff began, like I said, we timed it for 30 minutes. We captured all the volume and subsampled for analysis. So what did we find in terms of P runoff concentrations in this project? Here we're looking at dissolved reactive phosphorus, which is the soluble phosphorus in solution, and total phosphorus, which includes the soil sediment. Remember that phosphorus bonds to soil particles and moves a lot with the soil. This is a graph of every treatment that we used in the project, and you can see that with the 161-pound high rates of P2O5, that we got a good spike in concentration. But when you look to the right of the graph at the strip-till deep band, deep placement treatments, they were significantly lower. For the dissolved reactive phosphorus, all of those strip-till deep placement rates are actually equal statistically to the zero from the no-till broadcast. But then once you look at total phosphorus, which included that sediment movement, you get a higher number, but still in that range of the 92-pound rate for broadcast treatments. If you combine all that data and just look at it by tillage placement method, you can see a significant benefit from the deep placement at strip till and relatively similar numbers for both strip till and no-till broadcast. So to look at what that loss looks like in pounds per acre, we could calculate that using the concentration we found times the total volume and take that to pounds per acre. This graph is sorted by rate, so you can see fairly consistent data until you hit the 161s. 161 pounds per acre, you're getting a good spike in total load. But what's interesting is that for each rate, strip till deep placement always is giving us a reduction in that total load of P loss we had. When we conducted this study, we had runoff that was 2 to 3 weeks after the fall fertilizer application, and then we went back in the spring and conducted another runoff event shortly before planting. You can see that the spring here in the greenish color is fairly level, not very variable, but yet the fall numbers had a good spike. That's where we're getting the most variable concentrations. Again, strip till deep placement showing us a benefit over at the right, but with a slight increase when you get up to 161 pounds per acre. These volumes, or these concentrations, are low and seem low, but take into consideration that it only takes 0.015 to 0.03 milligrams per liter to cause a fresh body of water to become hypoxic. The state of Illinois currently has a standard for lakes, bodies of water, I think 20 acres or above, and that is at that 0.05 milligrams per liter, so it doesn't take much. These concentrations are also a little low compared to some other research, because that research is usually run off 24 hours after treatment, whereas we had a 2 to 3 week delay. So another piece of the puzzle we looked at was the soil available phosphorus. Again, this is a 6-year ongoing project where we had broadcast treatments that produced this surface nutrient-rich zone. So we've got a lot of phosphorus there available at the broadcast 92 and 161 pound rates. And when you look to the right of the graph, you can see that there's a lot less available at the surface. We had a good drawdown from that deep placement fertilizer. So the surface P is lower, and we showed some 4 to 8 inch data there to see that that's where we're concentrating that deep band. So we all want to know, in terms of these treatments, what kind of effect did that have on crop yield? For this project, we had 1 crop available each year. So in 2013 was the soybean year. It was just a good year for soybeans. We had very little variability across the whole project. And in 2014 was our corn year. We got a good yield bump when you move from no-till broadcast to strip-till broadcast, but yet no difference between strip-till broadcast and strip-till deep placement. If you look at yields by P rate, again, no difference in our soybean yields, and a small increase when you go from 0 to 92 pounds per acre, but nothing different at 161. So no yield increase was gained from going from 92 up to 161 pounds, a P205 per acre. If you look at yield across every treatment combination, again, it just reemphasizes that you had a little bit of a yield decrease due to the no-till broadcast, and the tillage effect from strip-till broadcast helped to raise, strip-till in general, raise yields a little bit, but really no difference between strip-till broadcast and strip-till deep placement. So all of that shows us the deep placement does allow for a drawdown of P available at the soil surface, which reduces our runoff potential. Deep placement gives us an opportunity to significantly reduce that P loss, even on the large area of Illinois that is fairly flat. And we also saw that moderate P application rates, such as 92 pounds of P205 per acre, generate significantly lower loss while still maintaining crop yield. There's a few other questions that weren't answered in this project that some of you might be thinking about, and that is deep placement similar to fertilizer incorporation? We didn't have that element in this project, but work at Iowa with Mallarino has showed that it's not always true that incorporation will work the same. It's very dependent on site management, because that tillage incorporation is still going to produce more sediment movement. We also just looked at one form of fertilizer in this project. So the question is how would that compare to manure? And Mallarino's found that manure actually has lower loss on some of his projects because the fertilizer had a higher soluble P rate. So what we found in this project is helpful for our 0 to 2% slope areas, but to assist the nutrient loss reduction strategy, more research is needed so that we have data for different areas with different management practices. Thank you.